So I'm going to just go back here in case you're watching the video. Oh, I need to have a microphone even. My goodness. I got distracted this afternoon. I had to, yeah, it doesn't matter. I had stuff that I had to do, and I did it. And now I'm, okay, testing. It's working. Okay, so we're going now. And just for those who just joined us, here's number 19. You can go slow or pause. And I gave up at that point and said, I don't want to do it anymore. But then Evan said he had the numbers. Yes. And then this one is just an example of what you might do. And here's another, not homework, not from the homework. Okay. We're moving on though. Translations on the t-axis. So we've translated through space. We're going to translate through time. So that's why I said it's just like last on Monday, because the next thing is, what did I say? That we're hopping on the TARDIS with Doctor Who to go through time and space. And so now we get to go through time. Now you're going to learn about a new function. This function has a name. It's called the Heaviside function. And I'm going to just make sure that yeah, there it is. So this, it's, here, I'll write down the correct name, but Heaviside, I think he's got an A in his name. Named after a mathematician, British mathematician by the name of Heaviside. I know, it sounds great, but it's actually kind of Dickensian in the sense that it really describes the function itself. The Heaviside function kind of feels like you're kind of heavy on one side. And let me show you what I mean by this. So this Heaviside function is also referred to as the unit step function. And so here is it literally. It is 0 when t is less than 0, and it goes up to 1 when t is greater than or equal to 0. So I can graph this thing, not hard. In fact, I've got this on the next slide, so I'll just graph it on the next slide. But this is what we call the Heaviside function. Now, I know you're thinking, why introduce a new function? We've had 17 years of mathematics courses. Never have I heard of this, or maybe you have, I don't know. Well, this just formalizes this idea of a piecewise function, that's all. And there's a good reason for it. And here's one good reason for a Heaviside function right here. Boom. See that? That was the Heaviside function in action. I'll do it again, watch. Amazing. Yeah, if you're watching the video, I just turned the lights off and on again, or on and then off again. Okay, so I'll explain why that illustrates the Heaviside function. Well, it has to do with that in RLC circuits. I know you've been enjoying those in your other classes. But anyway, getting back to this. What does the Heaviside function look like? It's also called the unit step function. Ooh, I don't like that version. I'm going to go back to this version. We'll get to the one from the book momentarily. So let me graph this. I wanted to graph it on the bottom. I'm going to graph it up here. So here's what this function looks like. It starts out, and it's 0. So far, so good. And then when you get to here, it jumps up. And then it goes on forever. I know, it's beautiful, isn't it? It's just a unit step. It goes up one. It's like you're walking upstairs. Here, I'm going to use the book as a proxy for a step. So I'm walking, and all of a sudden, I step up. Feels good, doesn't it? Down here, and then all of a sudden, okay, maybe that's too weird. Anyway, so that's the unit step function. I'm moving up one. Now, why is this useful? Well, what this does is it allows us to take a function and turn it on or off. So, for example, right now, I'm going to turn on the lights. And when I do that, it's as if I'm invoking the Heaviside function with this switch. So there is no electricity, no forcing function, no electromotive force going through those light banks up there. And then the moment I switch this, it changes to roughly a sine wave of current going through those lights. So boom, Heaviside function times the sine wave, and then I turn it off, and I take away that Heaviside function. So let's go ahead and formalize this or generalize it. In general terms, you can change the state of some sort of a system at any point. So if I've got my spring mass system, maybe I've got that, and now if you're watching the video, I'm holding my spring mass system up, and I'm just going to hold it stationary, but then all of a sudden I decide I want to move my arm because it's getting tired, and so I move it down. There's the Heaviside function, and now I stop moving it, another Heaviside function. So here I'll move it up. Okay, I can handle this for a few seconds, and then I'm going to move it down. Now, if you can see, when I move it down, it starts bobbing up and down at the bottom there. I know you can't see it, so I'll try to do the same at the top. I move it up, and I'll stop it. Ready? Up. As you would expect, the thing starts bobbing up and down. Anyway, so this Heaviside function, it can illustrate sort of, or it can represent the imparting of some sort of a piecewise function where it's not like there's a discontinuity in where that spring mass system is located, but there is a discontinuity in the forces that are being applied to it. Anyway, let's get back to this. This A here, that A represents, okay, A, hold on, I need to highlight this because it looks like I'm saying the word A instead of the letter A. Okay, the letter A represents, the time that you turn on the lights on whatever it is. I'm going to say the lights, but it's whatever it is that you're interested in. So here, let's just do this. I've got my timer here. Let's see, where's my timer? I was using it earlier. Okay, reset. So what I'm going to do is I'm going to do fancy U, notice it's a fancy U, of t minus 10, okay, t minus 10. So ready? I'm going to start. There. I know, that was so anticlimactic. I'm like, 10 seconds is a long time. I didn't realize. Okay, well, let's see. We can play around with this a little bit, though. You might say, how do we turn off the lights? Okay, well, we just turned on the lights. The Heaviside function turns on the lights. Well, you can guess that, maybe you can guess this, maybe you can't, but turning off the lights is the opposite. So here's how we turn off the lights, is the negative mu of t. Let's do it this way. T minus 5. How about that? Mu of t minus 5 minus mu of t minus 10. So here, this might be less painful to watch. Okay, so mu of t minus 5, start. Oh, start again. Oh. Stop, start, stop, clear. Sorry, I wanted to illustrate that, and I forgot that the lights have to start in the off position. Okay, here, let me graph this so that you see what I'm trying to illustrate. So this, I've got this, so here's my thing, and then, so here is 5, and here is 10. So we start off at 0, and mu of t minus 5, all that is it's been shifted over to here, and then it starts. So we have this, and we're up here now. There's 1. Now we move along, minding our own business, but then when we get to t equals 10, I'm subtracting another Heaviside function. So you have this one adds 1, and this subtracts 1, so it drops you back down to 0. So I can, oh, come on. Where'd it go? There it is. So I can go back down there. So that's what I wanted to illustrate. Okay, I know, painful. Let's do it. Just 10 seconds. So start. And 5. So I just turned on the lights at 5. And then at 10, there. I did my best to hit it right at 10. So, so that's what that would represent. Okay, so here's this. There's another example or a picture. So you might say, well, what is the big deal? What is the deal with this Heaviside function? Well, let's actually, not that one either. Here we go. That's not very exciting. That's not very exciting either. So I'm looking for something good. This is all boring. Here, I'll switch over. So let's take a look at this. Suppose that I want to do this. I want to take my sine function. So speaking of sine functions, and suppose I want to take that sine function, and instead of having this, I want to do this. That's terrible. There. I want to do it like this. So normally when you think of the sine function, it starts over there at 0 and then continues on its way. But suppose I want to start it right here. So shift over and start, how about, at pi over 3 instead of starting at 0. So in other words, my function or my forcing function or whatever it is going to be 0 until you get to pi over 3. And then all of a sudden I turn on the sine function. Well, here I have to do two things. I have to have my Heaviside function of t minus pi over 3. That's going to turn something on. Basically, that'll be 0 until you get to pi over 3. Then it'll be 1. But if I just do this times the sine, here's what you're going to get. You're going to get this, 0, 0, 0, and then all of a sudden you're up here. So that doesn't do what I wanted to. I want to be able to shift this whole thing over and start on the x-axis or the t-axis. And so to do that, what we're going to do is we're going to do shift the sine function as well. So hence this is why we say that we're shifting time now, is we're shifting the function through time. And hopefully you remember from your days in pre-calculus and trigonometry that when you do this inside a function, it shifts everything left and right. So here the t minus 3, it moves, or t minus pi over 3 moves everything over, and then it jumps up and down. Okay, so now what we want to know is how do we use this with differential equations? Well, maybe you don't want to know, but you're going to find out. So I just got to find the right, I have too much junk here. Why is there so much stuff? I think I know why. That's not what I want. Let's see. Where's my Laplace transform? That's what I'm looking for. The Laplace transform, we've already done that. Okay. Oh, actually that is, no, that's not what I want. Well, here it is, down here. Down there is the Laplace transform that we're looking for. Is the Laplace transform of the Heaviside function is just e to the negative as over s. So that tells you how far you've shifted over. All right, so let's see. Let me see if we can get this with another. Well, here, this we could just say it's all showing up at once though. But see if you can use that. So let me remind you that the Laplace transform. I'll put this over here. There we go. The Laplace transform of the Heaviside function t minus a is equal to e to the negative as over s. So do the Laplace transform of f of t. So here's the formula over there. I know maybe if I zoom out, there we go, good enough. So see if you can do the Laplace transform of that. We'll just do one term at a time. And I'll find some volunteers here. But go ahead and see if you can do those. There we go. Randomize. There we are. Oh, wouldn't you know it? The first person I choose isn't even here. Sad. Clayton's here, though. Clayton, do you know the Laplace transform of just the number 2 there?
Is it pair or something?
Something like that. Yeah, since it's a constant, well, it's going to have an s. And I'm going to put the s in the bottom, because it seems like that's where the s's all end up, don't they? They always end up on the bottom. So it's going to be something over s. Do you want to guess what the something is?
2.
Yeah, it's 2 over s. Yeah, this is in your table. So if I'd given you a quiz today, you'd be looking at that table. And you'd say, ah, yeah, it's 2 over s, or c over s, or whatever it is. All right, next one. Now the one that I actually have. So this is another item that's going to go on our table, by the way, is this Heaviside function. So next one is, who is the next volunteer? We got it, Peyton. Peyton, what about 3 times this u of t minus 2?
3e to the 2s over s.
E to the negative 2s, I think it is. Because this is, yeah, t minus a, and this is negative a. But yeah, very good. So you got 3e to the negative 2s over s. Now the last one, we got someone, oh, you are here. I looked at your name and I thought, Triton, you're not here, but you are. You're not going to be here Friday. But go ahead, Triton, what do you think of that last one? U of t minus 3. Can you do the Laplace transform of that?
Is it e to the negative 3s over s?
3s over s, yeah, that's it. So not too bad. These aren't horrible. So let's see. So this is where things get a little bit more horrible. And that is that in order to compute inverse Laplace transforms, you have to think in terms of shifting functions around. So let's do this in 2 stages. And I'm really displeased with that. I want to do the Laplace transform first. So I'll just switch over since I don't know what's happened to my PowerPoint. I think what's happened is that COVID happened. You know, this is right when 3 years ago we shifted to online, and I just haven't updated my PowerPoint. But anyway, let's do the Laplace transform of, let's do this u of t minus pi over 3 times sine of t minus pi over 3. So here's the deal. Let me write the rule down. The Laplace transform of u of t minus a times f of t minus a is equal to e to the negative as, negative as times the Laplace transform of f of t. Yeah?
Where did the over t go? Or sorry, over s.
Okay, it'll come back.
Okay, sorry.
No, yeah, the over s business is in here.
Okay.
Yeah. Let's. I think I've picked too complicated a problem to start with. We'll get there. Let's do this. Laplace transform of u of t minus 3 times 5. There. Okay, this is super simple. But here, let's, so using this formula. So if I were to do this using this formula, what I would get is I would get e to the negative 3s times the Laplace transform of the number 5. And then that's where that s came from, is that you would have e to the negative 3s times 1, or times 5 over s. Yeah, so the s, that 1 over s, it ends up getting embedded in that thing right there. But yeah, if the Laplace transfer, if you're doing the Laplace of a Heaviside function all by itself, then you just, write it over s. Otherwise, you just tack on an additional e to whatever it is. All right, now I think we can probably do this. I'll walk you through it. So let's walk through this one. First thing to note is because of this thing, I'm going to have e to the negative pi over 3 times s. So that's this piece. Now I've got to do that times the Laplace transform of sine of t. So take that in for a minute. Notice that I dropped the shift. You don't shift after you've done your Heaviside Laplace transform. So it's like doing that once you've done this piece, it's as if you've eliminated the need for this in here. Now there is a price to be paid for this, which we will see in a bit. But for now, there it is. Okay, so we've got this. Now you can just look this up in your tables. E to the negative pi over 3s. And we all know what the Laplace transform of sine of t is, don't we? It's 1 over s squared plus 1. So that'll be e to the negative pi over 3 all over s squared plus 1. You know, I just realized that my PowerPoint was correct in the sense that I was complaining about it, that I don't like the order, but yeah, what I was doing was the right thing, apparently.
Is it S or T?
Oh, it's S.
Okay.
S, there it is. See, I got T on my brain. So let's take a little break from this. Pause. And go back to PowerPoint land and see if you can do this right. Where is it? Where's the examples? There it is. Those two examples. Now I know that looks so complicated and scary. However, I think we can handle this at this point. Well, let's see if we can. So in order to do these, notice what you have here is you have a product of two things that I'm doing the inverse Laplace transform. So this is the opposite of what I just tried to do. So I have that thing there is going to result in a Heaviside function. And then this thing over here is going to get multiplied by that Heaviside function. Same thing goes over here on this one, that one. Okay, so let's see if we can do this. First things first, let's deal with the Heaviside function for this first one. So the Heaviside function, u of t minus what? So what am I doing t minus? Reagan, do you know what the t minus is for this thing here? It is t minus 2. Very good. So t minus 2. Next, we're going to go a little roundabout with this.
How did you get that?
Yeah, where did we get the 2? Reagan?
The T minus.
Yeah, so there's this thing. So yeah, where this stuff came from is if you ever have an exponential like this in your Laplace transform and you want to undo that, then you're going to have some, ooh, why is it doing that? Oh, I guess I have to continue to erase. There we go, that's the best I can do. So anyway, whenever you have this sort of thing, what that's going to do for you is it's going to give you a Heaviside function. So you have the mu, or the u, and then it's always going to be t minus whatever number is up here, t minus 2 in this case. And this is because the Heaviside, the Laplace transform of the Heaviside function is, let me see if I can find it here, I'll back up. This is slide 25. Where did I have it? Not there. There? No? There's too much junk here. I know it's here somewhere. I thought it was here. Whoops. Was that it? There it is. So notice that the Laplace transform of u of t minus a is e to the negative as. I know there's an s here, but let's just worry about the e to the negative as. So if we're going backwards, you take that as and it turns into t minus a. So that's sort of where the 2 came from in this right here. So, is that all right? So we'll do the same thing on letter B. But anyway, we're going to take a roundabout route to get the second part of this. the first thing I'm going to do is I'm going to ask, what is the inverse Laplace transform of 1 over s plus 4? So 1 over s plus 4, if you wanted to do that, you could use the table in your book, which I guess I could just show you my table in my book. Where's my book? Here it is. Let's go find that table. Because I know you don't have paper copies of the book, do you? Everyone found this gray market. Okay, yeah, it's black market.
Actually, it's the University of Rhode Island.
Is that where this came from?
Yes.
Let's see, is this where I'm looking for? Yeah, there it is. Okay.
Correct.
So there it is. Let me go put the, I'll toggle back and forth. So I'm looking for the inverse Laplace transform of 1 over s minus 4. And you will have this table that you can work with. So remember, it's 1 over s minus 4. Sam, do you see which one is going to be 1 over s minus 4?
That'd be e to the 14.
Very good. So e to the 4t, he's using letter C right here. So let's go back and we'll write that in. Remember, I'm taking a circuitous path to get to this. So it's e to the 4t. But then bear in mind that since there is a Heaviside function, I'm shifting through space and time, I need to do the same thing here that I have here inside the Heaviside function, and I get e to the t, oh, darn it, the 4. I forgot my 4. 4, t minus 2, there it is. Well, let me do another one, because, I mean, the more that we do, the more you'll say, okay, I see where it's going. So I know it's still super confusing. Let's go over here to this one and see if we can do this. So step 1 is let's deal with this. Let's deal with that. Just get the Heaviside function that corresponds with that yellow. So who's going to do this? You can do it. Write it down. Take a minute, and then we'll pick up a volunteer. All right, Jason, you can do it, can't you?
Yeah.
I'll get you started.
Pi over 2.
Pi over 2, very good. So this is pi over 2. Take a break, take a minute. No, it's a sort of mini break. Wow, it's almost time to go. All right, so what sorts of questions do you have about that pi over 2 that Jason can answer for you? Okay, you can always see him later if you want to know more about it. Okay, so that's that one. Now we're going to do this circuitous, here we go, over here first, and figure out what the inverse Laplace transform of the blue stuff is. And then once we get that, I'm going to rewrite it over here. So let's do this one at a time. Now notice it's s over s squared plus 9. So let's go back here to this table and look it up. S over s squared plus 9. So Ralston, do you see this on the table?
Cosine?
It is cosine, very good. Do you know which cosine? What value of k?
3.
3, yeah, very good. So it's cosine of 3t. So that's going to be step 1 as I say, oh look, the blue stuff, that's cosine of 3t. But now what I have to do is I have to take that cosine of 3t and shift it in the same amount as the Heaviside function is shifted. So this becomes cosine of 3 times t minus pi over 2. Let's try another one because I don't trust you to ask the right questions. So let's do at least a couple more. And then we'll unpause. Maybe we won't unpause till Friday. I may have bitten off more than I could chew on this homework that I assigned you. So here's inverse Laplace transform of e to the negative, no, why do I always get 5? Negative 7. I like 7. E to the negative 7s over s to the 5th. How's that? And let's do this. How about 12 out here, just for fun? Okay, so you're going to do two things. The first thing you're going to do is you're going to deal with the e to the negative 7s. So let me just highlight that and point down to this. So that's the first thing, is you got to figure out what you put in the parentheses there. And then the second thing is to deal with the rest of this stuff. And the rest of that stuff you're going to deal with in two stages. So you take that together, and you go over here on a piece of scrap paper, and you say, what is the inverse Laplace transform of 12 over s to the fifth? And then you'll take that and stick it down here after shifting. All right, so I think you can handle the yellow part. The yellow's easy. Aaron, what is this shift down here that's going to be indicated from that thing?
It's going to be t minus 7.
Very good, t minus 7. All right, next you may need to look this up in your table, so it might be helpful to actually have a table somewhere, but I'll tell you right now it's that letter B there. So here, I'll just go back to there, whoops, and see if you can compare that with letter B. And clean up my exponent there. All right, let's find a volunteer. Oh, not here to help. Sure, you could do it. You're not here either. What? Gabriel's here, though. Gabriel, what do you think? You want to put that back up here? I'm trying to do the inverse Laplace of this. Don't worry about the heavy side right now. Just this.
So it's just t to the fourth?
It is t to the fourth. So notice it's 1 over s to the fifth. And so 1 over s to the fifth corresponds with t to the fourth. Yeah, but what?
2?
Yes, it'll be over 2. So that was the next step, is I was going to say, wait a minute, I have 12 in the numerator there, and according to this formula, I should have 24, which is 4 factorial, that is. And so since I only have 12 there, I need to multiply by 1/2, or divide by 2, or what have you. So it's going to be 1/2 t to the fourth. So anyway, going back to the shift, what's going to happen is I multiply all of this times 1/2 times something to the fourth, and the something is the same as this something right there. All right, once again, still don't trust you. So I'm going to do at least, I think I'm not going to trust you until I see it next time. So I'm going to have to adjust the homework because I want you to be able to get this without losing your minds. And so let's try this. How about e to the negative 3t, s, darn it, e to the negative 3s all over s plus 4. That's an s up there. All right, we'll see if we can do it without writing down the extra stuff. Shelton, what do you think about the time shift? How far am I shifting? 3, yeah, so that's this right here. So that's pretty easy. That thing, you just stick it right there. So this will be 3. Now for the rest of this stuff, and the rest of this stuff is this right here. You might say, you didn't circle anything up in the numerator. Well, that's because that is just an implied 1, so I'll put the 1 there. So 1 over s plus 4, some of you have this memorized, I'll bet you do. Let's see if you do. If not, I can switch. Clayton, what do you think? Do you know what the inverse Laplace transform of 1 over s plus 4 is?
Something with sine.
So this would be the inverse Laplace transform of 1 over s plus 4. Technically, it would include sine, I suppose. Here, let me show you the table again, though. Yeah, so the inverse Laplace of 1 over s plus 4. Wait, did I zoom in too far? Yeah, I did.
E to the...
What is this? So the s plus 4, you're using this one, the one I've kind of zoomed in on. And what is the value of a if it's s plus 4? Yeah, negative 4. Very good, because of that minus there. So going over here, it should be e to the negative 4t. Going back there, I've got let's see, this is equal to e to the negative 4t, and then I can take that and shove it up here, and I'll get e to the negative 4, and make this t minus 3. And that's what that is. Okay, I'm scared, but I should not live in fear. Let me look at the homework, and what we'll do is we'll just do inverse Laplace transforms of these things for next time. So if you see any regular Laplace transforms, then don't do them. But here's the homework, just a sec. Here it is right here, and I will adjust it right now. There it is, 7.3. Wow, there's so many of them. Where is it? 7.3, 37, 39, 41, 37, 39, 41, 43. Yeah, just 43, 45, and 47 is all you get to do. Sorry. If you want to do them all, you can, but I'll move the others to next week. So that's it. So I hope you get a good day. Enjoy, and we'll see you on Friday.
What is it? What about it?
Maybe that's why I put it.
Is that one of the homework this week?